Hey everyone, I'm Damien. I'm around on Nostr. That's me. It's good enough. So today I'm going to be talking about Nostr Wallet Connect. I would argue that right now the current state of payments is a little bit outdated and could be upgraded. Right now, if you want to receive a payment and just say like, hey, this is how you pay me, usually you'll use a Lightning address, and that uses LNURL under the hood. And that works, but it's not the greatest experience, and I think that we have a lot of improvements that can be done. So the question then becomes about Nostr Wallet Connect. And with Nostr Wallet Connect, I think that we can enable Lightning payments everywhere in a more cypherpunk way than Lightning address does. So if you're interested in following along with these slides or you want a copy of them, here is a QR code. I'll include the link at the end too. But this will get you to the slides. In terms of who I'm speaking here to today, I'm talking to... Okay. Can I start now? Users. So anyone wanting to enable one-click, or anyone wanting to use one-click payments in a trust minimized way. And this is going to be fairly technical going into how exactly Nostr Wallet Connect works, but I think that it's important as users to understand the technology that we're using. And then this is also targeted towards developers and aspiring developers. So there's going to be a code example at the end that has a lot of documentation. And even if you've never written a line of code in your life, I think that this could be a good place to start. So we're going to be building at the end this simple wallet using Nostr Wallet Connect. So there's a few things to install if you want to try and follow along. So I figured I'd show this here now. If you use Nix, it makes it really easy to get going. So you can go to this determinate systems and paste this in and it'll start installing Nix. But if you go to this QR code, there's a link to my slides or to the project here, and it has instructions on how to start running the app. So if you need to install Nix, and then all you need to do, I forgot the most important part. Here you would run Nix develop, and so if you want to get started with that now, it can start downloading all of the things. Yeah. Why there's not tables? Tables in my... Oh, in here? I don't know. You didn't bring one? So what you will need to do is if you go to this GitHub and just copy that and type git clone, paste that in, then it'll clone it. And then you just run, I already have Nix installed, so you run Nix develop and everything is installed there. So it might take a little bit longer to get set up if you haven't downloaded Nix before. One second. All right, so getting back to the presentation, briefly on what is Nostr. Nostr is notes and other stuff transmitted by relays. This whole presentation is going to be kind of a crash course in Nostr along with Nostr Wallet Connect. But briefly, Nostr has clients that construct and broadcast what are called events. That's the notes and other stuff. And then there are relays which store these events and then stream them to those clients. The communication between clients and relays happens over WebSockets. And a client will create what's called a filter and essentially subscribe to the relay with that filter and say, hey, I want events that look like this. And whenever the relay gets them, it'll stream them over to the client. Best of all, Nostr is an open protocol. So there is a repository, the NIPS, that It defines what Nostr is, but anyone can add to it. And it has a simple event format that's the event format is consistent across anything that you're implementing in Nostr. So it makes it really easy to build on. Here is a link to the Nostr protocol repo, and NIPO1 defines what is Nostr. How do you start interacting with relays or building a client? So that's a good place to get started. We will talk about why Nostr Wallet Connect, what it is, some other solutions that attempt to accomplish a similar thing, such as Lightning Address. We'll go over how Nostr Wallet Connect actually works. It uses NIPO4, which is commonly used in encrypted DMs. NIP47 is where Nostr Wallet Connect is defined, so you can read up on these in the NIPS repo. And we'll touch briefly on NIP67, which provides a better experience for connecting your wallet to apps. And finally, we'll write some code and finish that wallet up. Nostr Wallet Connect is a protocol. It's built on top of Nostr, which is also a protocol. It uses Nostr as sort of a messaging layer. And what I mean by protocol is just a set of rules that two pieces of software understand, and through those rules, they're able to communicate with each other. In the case of Nostr Wallet Connect, this protocol facilitates communication between your Lightning wallet and apps. Here's a nice little picture from nwc.dev, which has some more documentation on Nostr Wallet Connect. You can see on the left, you have Bitcoin wallets, whether they're in your phone or in your browser. And through Nostr Wallet Connect, you're able to connect those to apps. We'll get more into how exactly that works, but at a very high level, that's kind of what it looks like. What are we trying to solve with Nostr Wallet Connect? We want apps to be able to interface with your wallet for a seamless payment experience. We want to be able to pay, but we also want to be able to receive into that app. And likely we'll want some sort of transaction data, so the app might want to show previous transactions, for example. Nostr Wallet Connect is not just for Nostr. And when I say that, I mean as in the social media apps. So there's things like Domus and Primal that are great use cases for Nostr Wallet Connect, because you can connect your wallet and then it just enables one-click zapping. You just click zap, there's no copy and pasting invoices or anything like that. But with Nostr Wallet Connect, we're just using Nostr as the communication layer. With that, we get some privacy benefits from Nostr. We get the ability to make asynchronous payments. So your wallet could be offline, but you could be on an app and make a payment, and it won't go through until you open your wallet again, but then that payment request will come in and you'll be able to pay whoever you're trying to pay. And it's relatively simple to implement compared to some other solutions. It's easy for apps and wallets to implement on both sides. And this is, again, a high level of what it will look like. We'll go through this flow in more detail later. But here we have an app and a wallet. So those are both Nostr clients. And then we have a Nostr relay. The app will send an event over to the relay saying, hey, pay this invoice. It could be sitting on that relay for a while and then get picked up by the wallet, because the wallet's asking, are there any invoices to pay? Once the wallet pays it, it'll send a message back to the relay saying, look, I paid it. And finally, the app can see that that payment was completed. With this, I would argue we could enable payments everywhere, whether it's e-commerce, gaming, social tipping, which is the use case of zapping, Patreon or course-like experiences. So maybe you want to pay for content one at a time as you consume it, or just subscriptions in general. And so any of these places where you would want to be able to make payments would be a great place to add Nostr Wallet Connect. Here also is a Discord bot that I made using Nostr Wallet Connect. So you can see, maybe you can't see, it's pretty small, but it says at the top that it zapped 616 sats to a total of 56 people. And all that took, I'll demo this in a bit, all it took was one command and all of these payments were sent. This is using Nostr Wallet Connect, but it's also using this API that makes building apps using Nostr Wallet Connect really simple. All you need to do is create a user with a Nostr Wallet connection. And so there's just simple post route to create a user. And from there, you will be able to make payments. You'll be able to make Prism payments. So if you've created 5 users through the Prism API, you can send a payment to all 5 of them. Receivers of payments also don't have to even be onboarded to the app yet. So you could spin up a user for them in the Prism API, and they can have no wallet connected, and people can start sending to them, and those payments will kind of be in a pending state. And then as soon as that user, maybe they've gotten enough balance that they're incentivized to connect their wallet. Once they connect their wallet, then all those payments will go through. And finally, with this API as a developer, you can attach fees to your app. So using the same concept of Prism payments, you are able to say, okay, maybe 1% of all payments that go through my app will get sent to this Lightning address. So anytime someone sends a payment, they're also paying the developer of the app. Here is a link to our website, makeprisms.com, where you could get API access, or come find me and I can give you an API key. There's also the documentation for it on there. That was just a bit of a sidetrack, but I had to shill my API. Here is kind of a rough outline of some other solutions and what features they have. It's fairly generalized, so don't take it too seriously. But we have pay invoice and make invoice, which are the 2 key features which they can all do. That's like, someone gives you an invoice, you want to be able to send money to them, and then you also want to tell people how to send money to you. We have Lightning Connect, which is implemented by L&D, and that is relatively difficult to implement on the wallet and client side. So I think that Nostr Wallet Connect provides a better solution than that. But overall, yeah, I'm not sure if that's accurate for the other solutions, but for Nostr Wallet Connect or async payments. So I, as an app, want to pay somebody, and I have my wallet connected. Can that payment go through right away, or can their wallet be offline? Yeah, there is no online. That's why I put it. Yeah. Yeah, that's why I put a question mark, because it doesn't, the idea of async doesn't really apply to custodial solutions, I would say. But again, I don't know, this is just kind of rough outline of all this stuff. But with all of this, what makes Nostr Wallet Connect stand out? I would say that it's because it's account-based. I meant to change this to individual connections, but same idea. Every time you connect to an app, you create a new account or a new connection, and that connection is unique to that single app that you are connecting to. And with this connection, you can have a budget and an expiry. You benefit from Nostr's privacy because every connection that you create is a unique key pair, and the app and the wallet don't even really know who's who or what they're talking to. They're just speaking the same protocol. And these connections are revocable, so you can connect to an app and you don't have to trust that app to later delete your Nostr Wallet Connect if you ask them to. You can go into your wallet and revoke this connection. And overall, I would argue it's the best way to connect your wallet to apps. So how does it work? There's apps, which are Nostr clients, and these apps send requests and receive responses. And then there's wallets, which it's a little bit not intuitive with the Nostr model, but wallets are also clients, and they're just using relays in the middle to communicate. And these wallets will receive the requests and send the responses. Nostr Wallet Connect has 3 event kinds. So kinds are a thing in Nostr where I said the events have a simple format. They're all the same format, but by specifying a kind, clients are able to interpret that event however it's meant to be interpreted. We'll go through requests, which are kind 23194, and responses, which are kind 23195. The full protocol flow, kind of going back to that earlier example, will look something like this. We'll have an app. In this case, let's say Amazon. So Amazon is a place where you'll create an account and you'll want to connect whatever payment method. Today it's credit card. And you'll want to come back over and over and over again. And you just want to click buy. You don't want to have to go through with the whole process of connecting your credit card or your wallet again. And then we have Albi as our wallet. This is just an example because Albi has the most support for Nostr Wallet Connect today. So step 1 will be to create a new connection on Albi. To create a new connection, we need a connection URI. This URI has some information in it, such as the protocol, the wallet's public key, the relay that this app and wallet will communicate over, and a secret, which is basically the private key for this connection. A full connection URI will look something like this, where it has Nostr plus Wallet Connect as the protocol, and then the wallet's public key, that relay, and the secret in there. And so this is almost like if you give someone this connection, you're giving them the ability to spend money from your wallet. So how do we get one of these URIs? There's a couple options. We could scan a QR code. I created this connection with a budget of 10,000 sats. So if someone can figure out how to get that into a app that supports Nostr Wallet Connect, they will be able to spend 10,000 sats from my wallet. But the cool thing about Nostr Wallet Connect is I'm comfortable giving a direct connection to my wallet because it only has a budget of 10,000 sats. And then there's Nostr Wallet Auth, which we'll get into, that makes this flow a little bit easier. The way that Albi handles connections is you'll go to nwc.getalbi.com, and assuming you already have an Albi account set up, the cool thing about Albi too is you can use this same interface, but you can connect your node to it on the back end so that you're not using their custodial wallet. But so here we see we're creating a name for this connection, and we're giving this connection certain permissions. So some of them are read your balance, get certain node info, look up the status of invoices, or what we care about for this example is sending payments. So we're saying this connection will have a budget of 100,000 sats and it will never expire. Then this is where the copy and paste or QR code comes in. You'll take this and then copy the connection into whatever app you're connecting to. So this works, but there's a proposal called Nostr Wallet Auth, which is defined in NIP 67, which is still not standard. It's still just a proposal. So you'll have to find it in Ben the Carmen's GitHub fork. The way that it works is from the app, you'll be able to click a button like connect to Albi, and that'll deep link you into whichever wallet you choose. And once you confirm the connection, the wallet will probably pop up with something like, you sure you want to authorize this connection? The wallet will send a Nostr event back to the app of kind 33194. And through this, the wallet and the app are able to collaboratively construct a connection without copy and pasting private keys. It allows the wallet to generate whatever it wants for the private key for that connection, and the app to generate its own key, and then they can manage their keys however they choose. The content within the event that goes back to them includes this secret, which is just kind of a unique identifier used for identifying this this communication between the app and the wallet. The wallet can tell the app which commands it supports, the relay it wants to talk over, and optionally even a lightning address. So I will show how this works. If we go to our Prism server, you can, this is the Discord bot. You can type /connect. And so here I'm trying to connect. We have this bot in here, and I'm trying to connect my Lightning wallet. Let's see if I can. So we'll type this /connect command, and I'll choose Albi. And Albi doesn't directly support NIB67, but this is a little wrapper that I made around it. So here's their connection page. All that we're wanting to do is send payments. So through NIB67, we're able to tell the wallet, hey, actually, we only just want to send payments. So that's all that it shows us here. And we could optionally add an expiry. And when I click connect, it'll redirect me to this page that is just a wrapper around Albi's setup that will end up sending an event back to the Zap bot. And we can see that we received that connection. And finally, Albi gave us my Lightning address. So I'll just say that I want to use the wallet's Lightning address, enter a default Zap amount of 21. And now I'm connected. So now I've basically enabled payments on Discord. So now what I can do is this zap all command, and I will zap only people online. Click send, zap 15 users, 21 sats each. And we can see does this show? Yeah, we see 5. Well, that was 3 hours ago. A few seconds ago, we sent all these 21 sat payments. Looks like some of them didn't go through. But you can see we didn't have to scan any QR codes. If this would be not a great user experience if you wanted to zap everyone in a Discord server and you had to scan all 200 QR codes. To pay on Discord, you will have to receive a payment on Discord, you'll have to be connected and have a Lightning address. Online is just people online in the Discord server, and then it will send, because it's using the Prism API, there's like kind of a state held of pending payments. So if there's users that aren't connected, yeah, the payments will expire after 24 hours. But the cool thing is we don't ever hold the payment or touch the Bitcoin. Because of Nostr Wallet Connect, we can just say this person, user A, owes user B 21 sats. And once they connect the wallet, then the payment from user A's wallet will go to user B. It doesn't, there's no payment that goes through because no payment takes place until user B connects. Yeah. All right, so however the app chooses to make you get a connection URI, you're gonna need one of those. So looks something like this. You have this string and you want to put it into your app. And so I don't know, I just put these purple suns here to show that the app and the wallet are controlled by the same entity. You're logged in as the same person on both accounts. And now the app and the wallet are connected, and they can communicate with each other over Nostr, which is a relatively public network, depending on the relays you're using. but they can have private communications because the event content is encrypted using NIPO4. So briefly, NIPO4 does the Diffie-Hellman key exchange, and what you will need are someone's private key and a public key. So in the case of Nostr Wallet Connect, we will have, if I'm an app, for example, I'll have my connection URI in the app, and that has a private key on it. And then I'll also have the wallet's public key. And so with this public and private key, I'm able to compute what's called a shared key, and the wallet is able to compute that same shared key because they know that connection's public key and their own private key. And once it's encrypted, it will look something like this, where we have the encrypted content in base 64 plus the initialization vector used in the encryption scheme. If you're using JavaScript, you could just use the Nostr tools library, which has NIPO4 implemented, and you'll just need the private and public key and then the content you're trying to encrypt or decrypt. So now that our app and wallet are connected, we're going to try to pay this invoice. And this invoice came from somewhere else. We don't really care where it came from. We're just concerned with paying the invoice in this case. It could have came from a Lightning address, or if the user that you're trying to pay has Nostr Wallet Connect that can make invoices, it could come from there. But just for once we have an invoice, when we want to pay it, the app, so say we're on Amazon and we're buying a product, we construct a request, payment request, with that invoice in it, and we send it to a relay. This request will look something like this. This is what all Nostr events look like in general. But for Nostr Wallet Connect requests, we have kind is 23194, and then the content is encrypted. And when it's decrypted, it will look something like this, where we have a method. In this case, it's pay invoice, and the parameters, which would be an invoice. And finally, there's a tag that has the wallet's public key so that the wallet is able to find these requests. These are some other methods that can go into those payment requests. We can make invoices, look up invoices, list transactions, and then there's a number of other ones. You can do multi-payments, you can get info about that connection, get the wallet's balance. So that request will go from the relay over to the wallet. The wallet will pick it up, and if everything's good, it will process that request and pay the invoice, and it'll get a message that says this invoice is paid. And now the wallet can send a response back to the app to tell the app that the payment went through. So this is a kind 23195 response that again looks very similar. It's just a different kind. The content will look the same when it's encrypted, but decrypted, it's a little bit different. We have a result type, which again can be those NWC methods, the potential result data, or error code, depending on if the payment was successful or not. And then the tags will be, instead of the wallet's public key, we'll have the app's public key so that the app can find this response, and the request events ID so that the app can connect the request to the response. These are the error codes defined in NIP47. So just depends on what goes wrong. You have this shows a unauthorized error code. So say you connected to an app and then later revoked it, and then if you try and make a payment through that revoked connection, the wallet will send an unauthorized error back. Finally, the app will receive that response and decrypt it and see that our wallet told us that it was paid. And it should, if it's paying an invoice, it should have a pre-image in there that you could verify that the payment was made, but we're also just taking, without that pre-image, we're taking the wallet's word for it. All right, so now we will build this as a wallet in the browser. Is there anyone that tried to get it set up and is having issues? Cool. All right, so what we need to do is I already cloned the project, and so I'll just open it up in Visual Studio Code, and we will say next develop again to get our development environment going, and then we just do npm run dev, and it starts up a development server on this URL. So this is our very simple wallet, and it will be using the Albi browser extension for WebLN. Tidwell showed us this secret trick where if you go in the console, you can do window.webln, and we can see here that we have a number of methods like get balance. We're going to use send payment. So right now it doesn't really work. If we try to see, maybe this, oh, I have to reset things. Oh yeah, so this is the current state of the repo. If you just clone it, is finished. So if you do git checkout unfinished, then it's unfinished. And if we reload, then this won't work yet, so we'll need to implement that. So going back to the slideshow, we have the first step. Guess I should show you the code base first. We'll take this. So this is going to allow us to subscribe to payment requests because we're a wallet, and so we want to listen for any incoming requests to us. But before I do that, I'll just show you this a little bit. I have this this is kind of some React stuff that doesn't really matter, but in here we have NDK. So this is using the Nostr dev kit, which makes building Nostr apps with JavaScript relatively straightforward. So we can create a new NDK instance, and what we're doing here is we have a set of relays that I think are defined here. They're defined actually here. So I'm saying this is the relay that we're gonna use. And what we do is we create a new NDK with that relay and then connect to it. It will also initialize a private key, or it'll get whatever private key is in local storage. And then there's just some utilities here to handle events and subscribe to those events, taking a filter and an optional or a required handler. So what will happen is in our main file, this is the index page that gets loaded up. We will copy what we took from the slides, and this kind of kicks everything off. So we create this new filter. This is filtering for requests to our wallet. So we have our public key, which we got from that use NDK hook. And so we're filtering for p tags with our public key, and then I just added this since field here to only get events after our page loads. And then we'll see, now that we have this, let me go back to our app, that we're subscribing to this filter. But nothing will really happen yet. So next, we need to add the ability to generate a new URI. So all of the Nostr Wallet Connect stuff happens in this use NWC hook. There's a lot of stuff left to do. So if you're trying to learn about Nostr Wallet Connect, you can go through and fill in all the rest of the blanks. But here we will add our generate NWC URI function, which essentially just creating a new private key. and then taking the information we already have, our wallet's public key and the relay, and sticking it all in that URI format. And then finally, we just save it so that when requests come in later, we can verify that this was actually a connection we issued. So now that we have this, we should be able to go back here and say generate NWC URI. And what we can do is we can take this and I'll go to Iris. I only chose Iris because there's no other, I haven't added any other Nostr Wallet Connect methods. It's not loading now. And a lot of the other Nostr clients expect you to have methods like get info and get balance, and they won't work. I don't know why this is not loading now. Well, we can try this demo app that I have. We will take our Nostr Wallet Connect and connect it in there, and we have 3 users, and these all just kind of have Lightning addresses hard-coded in, so we know how to get invoices from them. And what we can do is click Zap now that we've added that connection, and we should see we got some stuff here in the console, but it's all kind of empty because we haven't added the ability to decrypt events yet. So right now what's happening is when you click Zap, it's sending payment request, but our app doesn't quite know what to do with it. So next, we'll need to take that request and decrypt content of it. And if there's anything that in here, if you're going through this and don't know exactly what it's doing, ChatGPT is your friend. You could just copy and paste the function into ChatGPT and say, what does this mean? Tell me about it. Maybe you need to give it some more context, but it should give you a pretty good idea of what the function's doing. But in this case, we have our handle NWC request function, which we gave to that handle subscribe and handle function. So whenever a event comes in from our subscription, it'll get passed through here, and depending on, it'll first decrypt the NWC request. So this is coming directly in from the event, and then we will decrypt it. And how that works is we're using the Nostr tools library here. So we're just calling nip04.decrypt, and we use our private key and the app's public key, and then pass it the encrypted content. So now that we have this, we should see over here, we will send another zap, and maybe something will happen. We should get some more information. Oh, we already get the ask for the payment request. So here it decrypted the content. You can see it has pay invoice in it, and then has an invoice as a parameter. And finally, this doesn't send the request. Hello. This doesn't send the response back to here, and that's why these are still loading. So what we need to do to finish it off is add in here the ability to send the NWC response. So it's already mostly done. You can see we get the request ID from that request event, and then the app's public key is the public key that was used to sign the request. So we just take the public key off of that event. And what we need to do here is fill in these E tags with the event ID and the public key, and then also encrypt the content. So it's the opposite of decrypting, but it's using the same keys. It's using our private key and the app's public key. And then we're just constructing the result based on whether there is an error or a result. And we encrypt all that. And finally, we will just, using NDK, we can just publish that event to the relays we have. So what should happen now is I will just refresh things for good measure and send another zap. We get a payment request now. So if we go over here, same thing as last time, we'll pay this, and then it'll say publishing. This is the response event. This isn't quite finished. NDK will fill in the rest of these fields, but you can see we have the content that looks like gibberish. We have the tags, which is the E tag and the P tag, and this will get sent and not received. Let's try again. Pay it. It should send the response. And if this worked, it would show a check mark because it received the response. And there's a lot of things I didn't do in here. Like these fields are, this is where you would add a budget, and this is where you would add an expiry, and those could get saved alongside your connect. And then you would have here, I don't really do much to validate that connection. All we do is look in local storage and see if it exists. And if it does, we say, yeah, we probably issued this. But if you're giving your users the option to add budgets and expiries, then you'll need to keep track of the amount of sats that have been spent from that connection, and then check that to make sure that it's still valid, that the requests are still valid. And that's pretty much it. It's built so that you can just start adding methods. This handle NWC request will get the handler from our list of handlers. So if you want to make this a fully functioning wallet, you can go check out NIP47, which is where everything that we've done here is defined, how it all works. So we can see we have a number of other methods, right? We just used pay invoice, but we can implement all of these, and it tells you what parameters are expected and what is expected as the result. And I think that's pretty much it. Here's the link to the slides again, and Austin over in the other room he's making a bunch of workshops on plebdevs.com, and they're super great. I think I'm going to do a Nostr Wallet Connect. I'm going to probably build this wallet more in depth as a plebdevs workshop. So if you're interested, check out plebdevs. There's a bunch of just kind of workshops on getting started as a developer in the Bitcoin and Lightning space. That's all. Thank you.
Grandpa, why do you have so much Bitcoin?
Well, it all started in the year 2023 when I attended a conference called Bitblockboom.
What's Bitblockboom, Grandpa?
It was a conference where people talked about Bitcoin. This was way back when we used something called the US dollar for money.
What? Bitcoin wasn't always the world's money?
If it weren't for great speakers at Bitblockboom like Jimmy Song, Adam Curry, and Preston Pish, we'd all be living in pods and eating bugs. Instead, I was able to avoid fiat enslavement and secure generational wealth.
F***ing legend.
Be the legend your grandchildren deserve. Experience the best Bitcoin conference out there and join the Bitcoin revolution. Bitblockboom, the only conference for true Bitcoin maximalists. Book your tickets today at bitblockboom.com and use the code BBB1 for a special discount.